This video explains the Knut-Morris pattern matching algorithm, which is a computational technique that finds a pattern in a given string. For example, if we have a text S1 and we want to find out some pattern P in this text, then this algorithm can be used. The time complexity of the Knut-Morris pattern matching algorithm is order of m plus n, where m is the length of the pattern and n is the length of the string. The algorithm is based on the concept of longest prefix suffix or a pi table. This pi table is constructed from the pattern. When a mismatch occurred between the pattern and the main string, then we have to shift the pattern according to the pi table. We look at the value of the pi table, then we will shift the pattern according to those values. The time complexity of construction of this pi table is order of m, where m is the length of the pattern. Now let's see how do we construct the pi table. We are taking one string here and one pattern as this. Our purpose is to find this pattern in the given string. For that, first we have to construct the pi table for the given pattern. To create the pi table, we have used one array. Let's say P is the array where we keep all the pattern characters, and index are given as 0, 1, 2 till 9. There are 10 characters, so indexes are given as from 0 to 9. And in the second row, we will keep we will calculate the pi value and we will put it in these locations. This place indicates the pi value for this character A. This is the pi value for this character N, so on, so forth. The pi value of the first character is always 0. Then we'll take two pointers, one pointer at location 0 and one pointer at location 1. This pointer is denoted as j and this pointer is denoted as 1. Then we will compare the character at location j as well as the character at location I. Since both the characters are same, then we will take the index of j, we'll add 1 and we will fill this location. 0 plus 1 is equals to 1. Then we will increment the value of I to next location. This is I. And also we will increment the value of j to this location. This is j. Again, we'll compare these two values, A and B. They are not same. Since they are not same, so we will consider the previous value of j. Previous value of j is 0 and the corresponding pi value is also 0. So j will be moved to that 0 location. 0, j equals to 0. That is, it is decided by the pi value stored in this location. Then again we will compare the value at j and value at I. They are not same, but however at this point j cannot be backtracked. So we will increment the value of I to the next place and we'll put 0 in the location of B. This is I now. Again we will compare. This character A is same as character A. We'll consider the index of j, add 1 and we'll put it here. Increment both I and j. This is I. This is j. Again compare same value. So we will take the index 1 plus 1, which is equals to 2. Increment I as well as j. Compare the values. This is j, this is I. Compare the values. B and B are same, so we'll take the index and add 1. It is 3. Increment I here and j here, j here, and this time also same. So we will take the index 3 plus 1, which gives us 4. Similarly here also we'll move I and j, I and j will be moved. So 3 plus 4 plus 1, that value will be 5. Then we move the pointer I to the next element and pointer j also to the next element. This time these two characters are not same. So we will backtrack j, we'll look at the previous value of j, which is 4, and corresponding pi value is 2. We'll go to location 2. Here at this location, we will move the pointer j. So j will be now here. J is equals to 2. Again, we will compare this character B with the character A, not same. We will take the previous character A and its respective pi value 1, and we will move the pointer j to 1. This is j now. This time both these characters are same, a, and this is also a. So we'll take the index of j, which is 1 plus 1, which give you 2. Then increment I as well as j. A and B are not same, so we'll backtrack. In order to backtrack, we will go to location 1 and the corresponding value is 1. So j will be reinitialized to 1. J equals to 1. Then we'll compare these two values. A is equals to a. We'll take the index 1 and add 1, which is equals to 2. So after that, if we increment I will go out of this scope. I is equals to 10. So we'll terminate the process. Now, as a result of this algorithm, we have created the pi table. And in the next part of the video, we'll see how this pi table is used in order to find a pattern in a given string. Now, let's see how the KMP algorithm works in order to search a string. Here we have taken one example. This is the string and this is the pattern to be searched in the given string. For that, we have created a pi table for the pattern. Pi table, this is the pi table for the pattern. We will not go into detail of creation because we have already checked it, and you can do it yourself. And the values given in the pi table are like these are the pi values, these are the pi values. Okay, these are pi values. Now we will use these pi values in the searching process. First, we have placed a pattern directly under the first 6 characters of the main string. Now we'll take two pointers, one pointer I that points to the first character of the string or main string, and another pointer j that points to the first character of the pattern. Then we will compare these two characters. This is the string denoted by T and this is the pattern denoted by P. Then we will compare T of I with P of I. If both are same, then we will move the pointer, both the pointers I as well as J, to point to the next elements. So I will move here, I is equals to 1, and J will move here, J is also equals to 1. J is equals to 1. By the way, these are the indexes 0, 1, 2, 15, and 16. And these are the indexes of the pattern 0, 1, 2, 3, 4, and 5. We'll compare again. This time also they are same. So we'll move the pointer I as well as pointer J. I will point to location 2 and J will point to location 2 here. So at this point, character at I is not equals to character at J. So we need to backtrack the pointer J. To backtrack pointer J, we will look at the previous character of J. The previous character of J is B and its index is 1. So we'll go to the index 1 in the table and we'll consider the pi value. This case pi value is 0. So we will move the pointer j to the first element. j will move to the first element. Then again we will compare, we'll see that these two characters are not matching, so we cannot move backward the pointer j, so we'll move the pointer I one place forward. So I will go to this location, I is equals to 3. Then we will compare again. In this case, even the values are not same, c is not equals to a, so we cannot backtrack pointer j, we will move pointer I one place ahead, y equals to 4. Then we will compare both the characters, and these characters are same, so we will increment I as well as j, as well as j. This is j, this is I. Both values are same, we will increment I as well as j. Both values are same, so we will increment I as well as j. Now values are not same. If values are not same, then we will take the previous value of j, which is 2, and we will go to the second place of the pi table, 2, the location 2, and the value of the pi value at that point is 0, so we'll move the pointer j to 0. Then we will compare both the characters. They are not same, but we cannot move back the pointer j, so we will move forward the pointer I. Now characters will be compared. It will move forward till n equals to 13 and j will be equals to 5. Once we reach the end of string p, it means that this pattern is found in the given string. And in order to find out the position from where the pattern started, we'll take the value of I. In this case, I is equals to 14, because at the moment I is in 14 and j will be equals to 6. At this point will terminate, and if I deduct the length of pattern from 14, we will get 11, we'll get 5. 14 minus 5 is 9, plus 1 minus 1, minus 1 is equals to 8. That gives the location of the pattern that we found.